Next problem. Show that the point of intersection of the perpendicular tangents to a hyperbola lie on a circle. Right? So that is the first result. We are going to see the proof. Consider the hyperbola x square by a square minus y square by b square equal to 1. That is 1. We know that the equation of the tangent with the slope m to 1 is y is equal to mx plus or minus root of a square m square minus b square. So consider the tangent y is equal to mx. We are taking plus because there are two, plus or minus. We are taking plus mx plus root of a square m square minus b square. That is equation number 2. Let the equation of the tangent with slope m1 to 1 and perpendicular to 2 be y is equal to m1x plus root of a square m1 square minus b square. That is equation number 3. Right? So we are taking the equation of the tangent with slope m1 which is perpendicular to the tangent 2, right? So since 2 and 3 are perpendicular, hence m1 is equal to minus 1 by m, or m is equal to minus 1 by m1. Both are same, so we are taking m1 equal to minus 1 by m. That is equation 4. Using 4 in 3, the equation of the perpendicular tangent becomes y is equal to minus 1 by mx. We are replacing m1 by minus 1 by m plus root of a square into minus 1 by m square minus b square. So y is equal to minus x by m plus root of a square by m square minus b square. That is equal to minus x by m plus root of a square minus m square b square. So inside the square root we are taking LCM as m square. So we are taking that m square outside the square root. So it will become m in the denominator. So common LCM m, which is equal y is equal to minus x plus root of a square minus m square b square by m. So my is equal to minus x plus root of a square minus m square b square. So my plus x is equal to root of a square minus m square b square. That is equation number 5. Let p x1 y1 be any point of intersection of 2 and 5. Right? So first is tangent 2 and the perpendicular tangent. Right? That is 5. So 2 and 5. So p x1 y1 lie on both equation 2 and equation 5. Right? So put x is equal to x1 and y is equal to y1 in 2. So we will get y1 is equal to mx1 plus root of a square m square minus b square. So y1 minus mx1 equal to root of a square m square minus b square. Squaring both sides, y1 minus mx1 the whole square is equal to square root will go a square m square minus b square. So using a minus b whole square formula, y1 square plus m square x1 square minus 2m x1 y1 equal to a square m square minus b square. That is equation number 6. Put x is equal to x1 and y is equal to y1 in equation 5. Right? Because x1 y1 lying on both 2 and 5. So squaring both sides, m y1 plus x1 the whole square is equal to a square minus m square b square. So here we are going to use a plus b whole square formula. M square y1 square plus x1 square plus 2m x1 y1 equal to a square minus m square b square. That is equation number 7. So adding 6 and 7 we will get m square y1 square plus x1 square plus 2m x1 y1 plus y1 square plus m square x1 square minus 2m x1 y1 which is equal to a square minus m square b square plus a square m square minus b square. 2m x1 y1 get cancelled, plus and minus. Right? So x1 square y1 square. So in the remaining term m square is common. Take it outside, m square into x1 square plus y1 square on the left hand side. On the right hand side, a square minus b square, m square is common on the remaining term. So take it outside, m square into a square minus m square. So in the left hand side, x1 square plus y1 square is common. Right? Take it outside, x1 square plus y1 square into 1 plus m square equal to. Similarly on the right hand side, a square minus b square is common. Take it outside, a square minus b square into 1 plus m square. So 1 plus m square on both sides get cancelled. So you will get x1 square plus y1 square equal to a square minus b square. So locus of this point x1 y1 is x square plus y square equal to a square minus b square, which is the equation of the circle with the radius root of a square minus b square. Right? So the point of intersection of the perpendicular tangents to the hyperbola lie on a circle. Next result, the equation of the rectangular hyperbola is xy equal to c square when the asymptotes are coordinates axis where c is constant. So we know the equation of the rectangular hyperbola is x square minus y square, which is equal to a square, right? Because a is equal to b, right? We are using that idea, right? That is equation number 1. Now rotate clockwise, theta is equal to 45 degree. The coordinate axis is about the origin. So we are tilting the coordinate axis, right? So 45 degree we are tilting, right? Clockwise tilting, right? So x, this is y, this is c, this is rectangular hyperbola, this is the hyperbola, this is the asymptotes. So we are rotating the axis 45 degree. So let the new axis be x dash and y dash, right? This is the x dash, y dash, asymptotes. Let pxy be any point on 1 with respect to the x and y axis, right? Let x dash y dash be the point with respect to x dash y dash axis corresponding to xy, right? So by the transformation, x is equal to x dash cos 45 plus y dash sin 45. This is the transformation. We know how to transform the coordinate axis. From that we are getting, because theta is 45 degree, so we are rotating. So x becomes x dash 45 plus y dash sin 45, right? So x is equal to x dash cos sin 45 1 by root 2. Substituting the value, x dash 1 by root 2 plus y dash 1 by root 2. So x is equal to 1 by root 2 x dash plus y dash. Similarly, y is equal to minus x dash sin 45 plus y dash cos 45. So y is equal to minus 1 by root 2 x dash plus 1 by root 2 y dash. So y is equal to 1 by root 2 minus x dash plus y dash. So first one is equation number 2. This is equation number 3. Using 2 and 3 in 1, we will get 1 by root 2 square x dash y dash x dash plus y dash square minus 1 by root 2 square minus x dash plus y dash square equal to a square. So 1 by root 2 square means 1 by 2. Common, take it outside. So using a plus b whole square formula, x dash square plus y dash square plus 2x dash y dash minus, so here a minus b whole square formula, minus x dash square y dash square minus 2x dash y dash equal to a dash, a square. So that is equal to 1 by 2 x dash square plus y dash square minus 2x dash y dash multiplying with minus x dash square minus y dash square plus 2x dash y dash equal to a square. So x dash square y dash square get cancelled, right? Because minus plus. So remaining 4 x dash y dash, 1 by 2 4 x dash y dash equal to a square. Therefore x dash y dash equal to a square by 2. So that is equal to c square. We are taking a square by 2 as c square, right? So x dash y dash is equal to c square. So this is the equation of the rectangular hyperbola, right? Parametric equation of the rectangular hyperbola. So in general we are taking xy is equal to c square or c constant, right? That is the equation of the rectangular. Parametric equation of x square minus y square equal to a square. So we know the parametric equation of the hyperbola, a secant theta, b tan theta. For the rectangular hyperbola, a is equal to b. So we have a secant theta, a tan theta. So parametric equation of xy c square is, let x is equal to ct for some t not equal to 0. So x is equal to ct in xy is equal to c square. So cty is equal to c square. So ty is equal to c. So y is equal to c by t. Hence the parametric equation of the rectangular hyperbola xy is equal to c square is ct comma t by c, right? Thanks.